Hey guys, in this video we're going to talk about algebraic expressions. Okay, so we finally gotten to the point in this video series to talk about algebra. So what is algebra? Well, roughly speaking, algebra is the manipulation of numbers, letters, which are known as variables, we'll talk about that later, and operators such as addition, subtraction, multiplication, division. And algebra can be really useful. We can use it to answer mathematical questions. So this person right here is Al-Khwarizmi. He is known as the father of algebra. And so he helped invent a branch of mathematics because he had a lot of unique problems to solve. And so some of his problems, he needed a way to solve for unknowns when calculating areas of figures, in particular plots of land. Also needed to solve inheritance problems prescribed by Islamic law, find volumes of canals and buildings, and track the motions of planets. So this is only a few things that algebra can do for us. I mean, the number of applications that algebra has, I mean, we wouldn't have enough time to talk about all of them. But anyway, algebra is super, super useful, and in this video, we're going to talk about some pre-algebra concepts and just sort of work our way up to solving equations, to answering word problems, some real-world situations where algebra comes up. So anyway, let's move on. So first definition that we have. In algebra, we use letters to represent unknown numbers, and we call these letters variables. Okay, so alphabet letters. Sometimes Greek letters are used, such as alpha and beta. But in this class, we're going to stick to just the classic alphabetical letters. And so, so we can use these letters to represent unknown numbers. And so what I have is a statement here. It's an equation. The equal sign means is equal to. Right? That's what that equal sign means. So what this means is what number, okay, this is x, what number plus 2 is 3, is equal to 3. What number plus 2 is equal to 3? And we know what number that is. X has to equal 1. So what number plus 2 is 3? X has to equal 1. All right, how about the next one? 4 minus y equals 4. All right, so y is our variable, right? That's our unknown number. We're trying to find it. What is that? So 4 minus what number is 4? Well, that number has to be 0. 4 minus 0 is 4, and there's no other number that will solve this make this statement true, make this equation true. All right, so let's practice translating words into algebra. And the directions say use x as your unknown number. So we're going to be using x as our variable. Let's look at the first one. It says adding a number, so that's going to be x. Adding a number and 2 gives you 6. Okay, adding a number and 2 is 6. So the number I'm going to represent with x, we want to add it, so we're going to put the plus sign. What are we adding to a number? We're adding 2 to it, and the result is 6, so this is going to equal 6. Okay, adding a number and 2 is 6. That number has to be 4, but it just asked us to translate this into algebra. So that is this statement in math, in algebra. All right, let's look at number 2. Multiplying 5 and a number gives you 10. So multiplying 5 times a number, again, we're using x for our number. And typically in algebra, we don't use the x to indicate multiplication. Instead, we either use a dot or we don't write anything at all. Okay, so instead of the x for multiplication, I'm just going to put a dot. So that's multiplication. So multiplying 5 and a number, which we're calling x, gives you 10. So the result is equals 10. And we know that number has to be 2, all right? So x has to equal 2 there. All right, looking at number 3, the difference of 7 and a number is 1. So difference means subtract. So the difference of 7 and a number x, so 7, the difference of 7 and x is equals 1. So the difference of 7 and a number is 1. And we know what that number is. That number has to be 6. 7 minus 6 equals 1. The product of a number and 8 is equal to the sum of that number and 9. All right, let's break it down. So the product means multiplication. Product means multiplication. The product of a number. So we have x and 8. So we're multiplying x and 8 first of all. So x times 8. The product of a number and 8 is equal to. So I'm going to put an equal to sign. The sum. Sum means add. The sum of that same number. So that same number and 9. All right. So the product of a number and 8 is equal to the sum of that same number and 9. All right, so that's how we translate this into algebra. Okay, so let's talk about our next definition. An algebraic expression is a mathematical phrase that contains numbers, variables, and operators. And as I mentioned before, operators can be plus, minus, times, division, square root, etc., etc. Okay? So here's some examples of algebraic expressions. We have a plus b minus 3. That's an expression because it consists of variables a and b, number 3, and operators plus and minus. Right? So that's an algebraic expression. And you guys can go through the rest of these. All of these are algebraic expressions. Notice that there's no equal sign. Okay, so that's an important distinction. That is an important distinction. An algebraic expression does not have an equal sign. We're going to get to that later, but if there is an equal sign, it's called an equation. So all of these things that we wrote were all equations. These are all equations, not expressions. Now we have expressions on each side of the equation. So on the left side of the equal sign is an expression, and on the right side of the equal sign is an algebraic expression. But if we look at it as a whole, these are all equations because of the equal sign. So anyway, each of these are algebraic expressions. Even just the number 22 is an algebraic expression because it does consist of a number. There doesn't need to be operators or variables. You can have just a number, you can have just a variable, or you can have a combination of numbers, variables, and operators. Now, you can't just have an operator. I mean, that doesn't even make sense. Like if I literally just gave you a division sign, that's not an algebraic expression because it's not. But anyway, yeah, these are all examples of algebraic expressions. Okay? All right, so another vocabulary word. An algebraic expression is made up of one or more terms. So simply put, a term is just anything that's stuck together with multiplication. Terms are separated by a plus or minus sign. So some example of terms, we have negative 4x. And as I said, guys, we don't write, in algebra, typically we use a dot or we don't write anything at all to express multiplication. So negative 4x actually means negative 4 times x. That's what that means. It's all stuck together. There's no sign in between the negative 4 and the x, so that's multiplication. All right, so, and, another one, this guy, okay, so these are all terms because everything's stuck together with multiplication. This guy means negative 6 times w times y squared. That's what that means. So anything stuck together with multiplication is a term. You could have a really simple term with just a single number or a single variable, that's totally fine. But terms are can be separated with plus or minus signs. So here's some more definitions that we're going to refer to in the next coming slides. I know this isn't the most interesting thing, but it is pretty fundamental to know this stuff before we delve into the actual fun stuff, the algebra and the problem solving. So here's another definition. A constant is a fixed number or value. So for example, the numbers 1, 8, -3, these are all constants. A coefficient is a number that's being multiplied by a variable. For example, in the term 3x, the number 3 is the coefficient because it's being multiplied by the variable x. In 2y, 2 is the coefficient. In -3z, -3 is the coefficient. In 5ab squared, 5 is the coefficient. Okay? An operator is an operation between terms. So as I mentioned before, plus, minus, times, division, square root, all of these things are operators. So let's do some practice identifying the variables, constants, coefficient, and terms in this expression. Okay, so the easiest thing I think is the variables. And you don't have to write, like if there's a variable squared, you don't have to write the squared. So in this is an algebraic expression because there's numbers, there's variables, and there's operators, plus and minus signs. Okay, so, and no equal sign, that's important too. So this is an algebraic expression, and we want to identify the variables, constants, coefficients, and terms. So the variables are all the letters that we see. I see a W, I see a X, I see a Y, another X, but we don't have to count the X twice. So the variables are going to be W, X, and Y. Now the constants are just the numbers, not attached to variables. Okay, so the constant here, there's only one, it's just -8. Right, the constants are numbers that are not attached to variables. Okay, the coefficients are the numbers that are attached to variables. So the coefficients, we have 2 because that's attached to a W squared. So we have 2, we have 3 because it's attached to xy, and we have 3 over here, but we don't have to write the 3 twice. We already wrote it. And terms are going to be anything that's stuck together with multiplication, and remember, terms are separated by plus and minus signs. So the first term is the 2w squared. This is all attached by multiplication. It's 2 times w squared. Okay, so the first one is 2w squared. Then comes the plus sign. Okay, terms are separated by plus or minus signs. So the next term is 3xy. That's all being multiplied. Followed by the next term is -8. Because it's not just 8, it's because there's an understood plus in the front, right? Remember from a few videos ago, a plus and a minus makes a minus. So this is actually plus the term -8. So the next one is -8, followed by 3x. So these are all of our terms. All of these are separated by plus and minus signs. Okay. Okay, moving on to the next one. So I encourage you guys to pause the video at this point, identify your variables, constants, coefficients, and terms. So variables, the first variable I see is x, the second variable I see is y, then I see a z, and that's it. X, y, and z are variables. Our constants are the numbers that aren't attached to variables. So all I see here is -3 is the only constant. Our coefficients are the numbers that are attached to variables. So the first one we have is 9 because that's attached to x squared. Then we have a -4 because it's attached to x, y squared, z. Then we have a 2 that's attached to z squared, and that's it. Finally, our terms, or anything that's separated by plus and minus signs. Now if it's separated by a minus sign, we're taking the minus sign with us. So the first thing that is like a chunk attached with multiplication is 9x squared. Then comes a minus sign, so we know that we stop there, okay? So 9x squared is our first term, followed by everything that is attached there. Now there's a plus sign, so that means we stop, right? So the next term is negative 4xy squared z, okay? All right, the next term is 2z squared, and we stop there because of that minus sign. And finally, our last term here is just negative 3. Okay, so those are all of our terms. Things that are separated by plus and minus signs, okay? Let's look at number 3. All right, so variables. This is pretty straightforward. All we see is x, all right? So that's our only variable. Now, what I want to do before I go any further is I actually want to rewrite this, because notice that we have a common denominator between the two terms on top, okay? Because if you had something like 2/3 minus 1/3, couldn't you write that as 2 minus 1 over 3, right? Okay, we're going to apply that same logic, but go this way, go backwards. So this is like the 2 minus 1, right? And this is like the 3. So we can separate this into two fractions just like this, and because that's going to let us see what our terms are a little bit better. So we can separate this guy. We can say, well, this is the same thing as x squared over 5 minus 4x over 5. Same exact thing, just by using the same logic that we use with real numbers, with fractions. Okay, so we can separate it like that. And then I can write this a little bit more clear so that I can see what the coefficients are a little bit better. This guy right here is the same thing as 1/5 x squared. That's the same thing. Why is that the same thing? Well, because 1/5 times x squared over 1, if we multiply straight across, is x squared over 5. Same exact thing. I like to write it like this, okay? Because then it's easy to see what the coefficient is, right? Here, not so much. So that's that. And same logic applies to this guy. This guy is just negative 4 over 5 times x, okay? Same logic. So now we can identify everything a little bit easier. As I said, the only variable we have is x. So again, I'm looking at this right here. The constants, we don't have any constants because there's no number that's just by itself without a variable attached. So there's no constants. The coefficients are the numbers attached to the variables. We have two. We have this guy is attached and we have this guy is attached. So 1/5 is attached to x squared and negative 4/5 is attached to x. So those are our coefficients. Our terms, we have two of them. The first one is 1/5 x squared, and the second one is negative 4/5 x. Okay. All right, final one on this page. So everything looks good in terms of we don't have to separate any fractions like in number 3. So for our variables, the first variable I see is a. The second one I see is b, and that's it. So our variables are a and b. Our constants are going to be the numbers alone that aren't attached to variables. And so I don't see any number that is not attached to a variable by multiplication. So no constants. Next is coefficients. So coefficient, those are the numbers attached to the variables. First one we have is 8. Second one we have is negative 3/5. Third one we have is 6. Okay, and those are all of our coefficients. Our terms, anything separated by addition and subtraction signs. So the first chunk, our first term is 8a squared, then comes a minus, so that signifies the end of the term. Second term is, so remember this is the same thing as plus minus 3/5 AB. So our second term is negative 3/5 AB. That's all attached with multiplication. Then comes a plus, and that's how we know to end it there. After the plus sign comes 6b squared. So that is our last term. So those are our three terms. Okay, so let's talk about our next definition. I know this is a lot of definitions, but we gotta get through them to move on because they're important. It's important to know these fundamental things before we start getting serious. All right, so the word polynomial means many terms. For those of you going into the medical field, you probably study a lot of Latin roots and stuff like that. Poly means many. Okay, so polynomial means many terms, and a polynomial consists of terms that are being added and subtracted. Okay, so such as 2 plus x, 5a minus 6ab plus 3b to the 4 minus 4x to the third plus 6x squared minus x minus 7. These are all examples of polynomials. So I'm going to give you an example of something that isn't a polynomial, and we're going to really get into this probably in college algebra when you guys take that, but for now I just want you to kind of know that this is not a polynomial. If we have a variable in the denominator, that is not a polynomial. Okay, so polynomial. Now there's different categories of polynomials that we're going to talk about, and again, this is a little bit boring. I'm not gonna sugarcoat that. This is a little boring, but it is important to know the vocabulary because I'm going to be saying these words as we move on. When we're solving problems, I'm going to be using this vocabulary, and if you know it early on, it's going to make learning the actual math much easier because it's less, it's less mental strain if you already know what these things are, I guess. Okay, so the first type is a monomial. The prefix mon means one, okay? So monomial means one term. That's what monomial is. So some examples, we have x is just one term, just stuck together with multiplication. 3y is a single term because 3 and y are attached implicitly by multiplication. 46 is another monomial, just a single term, okay? Next comes binomial. The prefix bi means two. Okay, so this is two terms. This is an expression with two terms. For example, x squared plus x is a binomial, right? Because we have the first term x squared and the second term x. The second example of a binomial is y plus 3. First term is y, second term is 3. Okay, and finally we have trinomial, and you guessed it, three terms, right? The prefix tri means three. So here's an example of a trinomial. We have three terms. This is a single expression, right? Because it's just terms and operators and variables. And we have three terms all separated by plus signs. So this is a trinomial, all right? So let's practice labeling each of these expressions as a monomial, binomial, trinomial, or none of these, okay? So the first one, we have this guy and we have this guy. So we have two things stuck together with multiplication. Remember, there is an implicit plus sign right here, okay? So this is 6x cubed plus negative 5y. So this is two terms, okay? So that means it's a binomial, right? Now this guy, we don't have any plus or minus signs. There's just a single chunk, 8x squared y. This is all being multiplied. So single term means monomial. Okay, let's look at the next one. We have something all multiplied, a plus, something all multiplied, a plus, something all multiplied, a plus, and there's our final term. So 1, 2, 3, 4 terms. This is none of these. All right, for a trinomial, we need 3, but we have 4 here. And that's because there are 4 terms. Okay, next one, we have x squared. That's a term. plus a negative 5x, that's a term, plus a 6, that's a term. So 1, 2, 3 terms, this is a trinomial. Okay. 2x, so that's just a 2 times x. It's attached by multiplication. There's no plus or minus signs, so this is only one term. This is a monomial. Okay. All right, so the next thing we're going to talk about is writing expressions in standard form, okay? And the way that we do that, it's pretty simple. We just write the term with the greatest exponent first, and then we go in descending order from there, from left to right. And we write the constant last, okay? So we call this writing an expression in standard form. So for example, if I gave you this and I said, hey, write this in standard form, we want to write the highest exponent term first. Now there's two terms, there's this one and there's this one. Okay, so the constant goes second and the term with the highest exponent comes first. So 7y squared, again, is a term because that is all stuck together with multiplication. There's no plus or minuses separating them. So 7y squared and then a positive 3. There is a positive right there. It's not shown, but that is an understood positive, okay? So this is 7y squared positive 3. That's in standard form. Let's do some more practice writing these guys in standard form. Okay, so the first one, let's first circle our terms. So we have this guy is all multiplied, this guy is all multiplied, this guy, and this guy. All right, so those are I have 4 terms here. And the term with the highest exponent is this guy. This guy has a 3 in the exponent. Okay, that's the highest exponent, so he comes first. So we have 10x cubed, followed by the second highest exponent, which is 9x squared. So it's a positive 9x squared. Remember that that plus sign is understood to be in the front. Now this x, it has an understood exponent of 1. Okay, so that has an understood exponent of 1, so that comes next. And finally, the constant number is 5 over 2. There's no x there. So this is just plus 5 over 2. And this is our answer in standard form. We started with the highest exponent term, and we go in descending order until we get to the constant. If there's no constant, that's fine too. We don't always have to have a constant. Let's look at the next one. So first I'm going to circle my terms. I have this guy as a term, all stuck together with multiplication, plus, remember there's that plus right there, this term, all stuck together with multiplication, plus this term, plus this term. So what's coming first? Which one has the highest exponent is this one, right? That's a 5. That is higher than 4 or 3. So first comes a to the 5th, followed by the term with a to the 4th, which is negative 0.9, a to the 4th, followed by a positive 5a to the 3rd. And finally, my constant is positive 7. So this is my answer in standard form. All right, next one, our variable is z, and it looks like this is my first term. Remember, there's this plus sign, y'all. This is my second term, and this, oops, let me do this again. This is my second term, and this is my third term, okay? All separated by plus signs. So the highest exponent is definitely 3, right? So we have negative 0.8 z to the third comes first, followed by a exponent of 1, which is plus 3.2 z to the first, but we don't write the 1 there. And finally, the constant comes last. So there is no z to the second, but that's okay. We still go in descending order by exponents. Okay, let's do the last one here. So I'll circle my terms. I have this guy's a term, 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 and this guy's a term. And remember, with those minus signs, we have an understood plus there. Remember, these are all separated by plus signs. All of our terms are separated by plus signs. So what's the highest exponent? That's going to be 8. Okay, so that guy comes first, and he has a negative in front of him. So negative m to the 8, followed by the next highest, which is m to the 6th. So positive 1/2 m to the 6th, followed by m to the 5th. Okay, so this is going to be a negative m to the 5th. Don't have to write those orange plus signs. That's totally fine. Next is 3. It's our next highest, so that's negative 16 m to the 3rd, followed by a positive 8m, and finally our constant, which is positive 2. So this is our answer in standard form.